Alright, welcome to video 4, which is all about learning how to run Pearson's chi-square analysis. And we run Pearson's chi-square analysis when all of our variables, both our IV and our DV, are both categorical, both having to deal with groups. And so this is when we have nominal variables and when we have ordinal variables and we want to treat them as such, as groups, not like we want to treat them where we calculate means and standard deviations. So for example, if we're looking at what students did in terms of what did they do when they encountered a zombie? Did they decide to run and hide? Did they scream? Did they fight? Or did they call and text someone? We want to know, depending upon what a student did they do one of these 4 things? Did they end up getting infected or not? And this might be good, again, as a zombie health science researcher. You might want to tell your students and the rest of the students stuck here at Cal State Fullerton, the better chances of you surviving and not becoming infected is if you do this. Run, hide, scream, fight, or call and text somebody. We're not sure, so let's find out. Steps 1 and steps 2, again. Same old thing like we've done previously. Step 1, stating the null hypothesis. And we're simply stating that there are no differences among whatever our groups are on whatever the dependent variable is. Remember, all of our variables, both of our variables, all have to do with categories, all have to do with groups. So there is no difference among students' actions on whether or not he or she got infected. But stating the alternative hypothesis, this is where it becomes a little tricky. How many groups do we have for a dependent variable? How many options are there for students' actions? Do you remember? We have run and hide, 1, fight, 2, scream, 3, and call and text somebody, 4. Because we have 4 different groups for our independent variable, I want to see, is there a difference among these groups on our dependent variable, which is whether or not someone got infected. Because we have multiple groups, we can't just say that there is a difference, because we're not sure where that difference is. So we have to really say that there at least one group is different from at least one other group on our dependent variable. So for example, at least one student's action is different from at least another student's action on whether or not he or she got infected. And the reason for this is because we have more than 2 groups. We have 4 groups in this case. In order for us to reject the null and accept the alternative is that at least one group differs from another group in regard to the dependent variable. At least 2 groups differ, we will go ahead and say that we're going to reject the null. Not all 4 groups need to be significantly different from each other. There just needs to be one group that differs from the others, or one group that differs from at least one other. And we'll learn how we're going to write out the equations for the null and alternative hypothesis when we're working with chi-square. One thing because we have multiple groups, and another because we don't have means. Thus far, we've written our equations when we have means. Right? We want to look at the difference between kids who eat fast food regularly and those who don't on their BMI levels. BMI is a number. We have a mean for both of those groups. In this case, we don't have means because our variables are both categorical. So we'll see how we write out the equations for chi-square hypotheses in the coming weeks. So let's go ahead and move on to step 3, which is obtaining and calculating our test statistic. So this time we're going to go to analyze like we've done before, but instead of comparing means, because we don't have means, we need to go to descriptive statistics and go to crosstabs. So let's go ahead on over to SPSS. Alrighty, so we want to look at whether or not there's a difference between what students did in terms of action and whether or not they got infected. So let's take a look at our variable view. and take a look at our variables just a little bit more, just to kind of refresh what we're looking at here. So what did you do when you encountered a zombie is our action variable, and we see we have run and hide coded as a 1, fight coded as a 2, scream coded as a 3, and call or text someone coded as 4. And then whether or not someone got infected, we've seen this before. No is a 0, yes is a 1. So we want to run a chi-square analysis to see, is there a difference between what students did when they encountered a zombie and whether or not they got infected. So we're going to go to Analyze, Descriptive Statistics, and then click on Cross Tabs. So we have this window that pops up. Our rows are going to be your independent variable. And in this case, our independent variable is the action. What did students do? So we'll click on Action and move that into our rows box. And then our column is then going to be which variable? Our dependent variable. And in this case, whether or not somebody got infected. So infected, move that into our columns box. Okay, now that we've identified our independent and dependent variable, let's go ahead and click on a few more options before we actually run the analysis. Don't worry about exact, but you want to click on statistics because we want to get our chi-square statistic. This is our test analysis that we're doing. Then we want to click on cells, and by default you should have observed checked. We also want to include expected counts and your unstandardized residuals. Then click on OK. Now we can click on OK to run our analysis. So here's our output window, and we see we have 3 different tables. So let's take a look at the first table. This is simply giving us our case processing summary. It's just telling us what our 2 variables are. What did you do when you encountered a zombie, and were you infected? And we see valid cases, 20, 100%. There are no missing cases out of our total 20 sample size. So we see everybody was included in this analysis, which is we wanted. You may still have 13 here. If you have 13, that means you did not deselect cases from when we did our dependent samples t-test. Go back to video 3 to see how we deselect our cases. Okay, so let's take a look at our second table. This is our cross tabs table. What did you do when you encountered a zombie? Star, were you infected? So this is really just the cross tabulation between these 2 variables. And so if we look, what did you do when you encountered a zombie? Again, our rows. Our rows are our responses to our dependent variable. Run and hide, fight, scream, and call and text someone. And then we see on our columns, were you infected? No or yes. So how many people decided to run and hide when they encountered a zombie? Ten. How many people were infected? Well, we know previously 7 were, and we can see down here our total 7. So now how many people who decided to scream when they encountered a zombie became infected? 2 students, right? We have our screamers here, and then we have, were you infected? Yes, 2. And this 2 is our count. This is our observed count. What do we actually see in our data, in our sample? This whole row of expected count for each of these rows is really what did we expect to see if the null hypothesis is true. And remember, the null hypothesis in this case is that there's no difference between what a student did and whether or not they were infected. So if we expect that there are no differences, that no matter what a student did had no effect on whether or not they got infected, that if we expected that somebody who decided to run and hide, we would expect out of those 20 students that 3.5 of them would become infected, and 6.5 of them would not become infected. And the residual is simply the difference between what do we actually see, what is our observed count, minus our expected count. And we'll talk about this again in much more detail when we learn about chi-square. So that's the crosstabs. Let's look at our actual chi-square test. At this point, we have not completed step 3, which is obtaining our chi-square test statistic. That's what our last table is. Chi-square test, we see Pearson chi-square value. This 13.407 is our test statistic. It is our chi-square test statistic. We have our degrees of freedom of 3, and then we have our p-value of 0.004. Again, we see sig. This asymp in front of the sig just simply means asymptotic, one of our properties of the normal distribution. So we see our p-value is 0.004. So we compare this to our alpha level of 0.05, and we're then going to do what? Accept the null or accept the alternative. Because our p-value is less than our alpha, we're going to reject the null and accept the alternative and say that yes, there is a significant difference between what a student did and whether or not he or she became infected. Just completed step 4. So let's go back to our presentation to round off our hypothesis testing for chi-square. Steps 4 and 5, again, we made our decision based upon looking at our p-value. And we're going to state in step 5 that there was a significant difference among students' actions and whether or not they were infected. Chi-square, 13.401 with 3 degrees of freedom. P is equal to 0.004. Because there were significant differences, we then elaborate more and describe what those differences are. A higher proportion of students who ran and hid were not infected. But those students who fought, screamed, or called and texted someone had a higher proportion of being infected. So in layman's terms, the whole idea of doing this analysis was to see whether or not you can tell a student, run and hide, or call me if you encounter a zombie, and the chances of them becoming infected. Well, we see that students who decided to run and hide had a significant difference in not getting infected compared to students who decided to fight, scream, and call or text someone. Because those who decided to do that actually had a higher proportion of becoming infected. So tell your friends, run and hide. Don't try to fight it off, or don't call me and tell me you see a freaking zombie. Get out of there. That'll be your best chance of survival. So to summarize, chi-square analysis, we look at the third box that tells us whether or not we reject the null hypothesis and say that there is a significant difference, or we fail to reject the null hypothesis and say that there are no significant differences. And we look at our second table, the contingency table, or our crosstabs table, to really look at our observed and our expected counts. And then if we see significant differences, we look at the residuals to help us explain where those significant differences lie. Always report your chi-square test statistic, your degrees of freedom, and your p-value. And then again, if significant, describes how the groups differ and don't differ by utilizing your residuals to help you describe it.